In this episode, we take the idea of backups and recovery and push it one step further into the part that separates hope from confidence, proving that recovery actually works. Many organizations feel safe because backups exist, but backups that cannot be restored under real conditions are not protection. They are just storage. Recoverability is the ability to bring systems and data back in a usable, trusted state after something goes wrong. That ability has to be demonstrated, not assumed, because failures often hide quietly until the worst possible moment. The focus here is restore tests, integrity checks, and documented results, which together create evidence that recovery is real, repeatable, and dependable. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. A good place to begin is with a simple truth that beginners sometimes find surprising. Successful backup creation does not guarantee successful restore. Backups can be incomplete, corrupted, encrypted with missing keys, or stored in a way that is inaccessible during an incident. Even when the backup files are fine, the restore process might fail because required settings, dependencies, or permissions were not captured. You can also have logical failures where the restore completes, but the recovered system does not function as expected because something important was left out. That is why recoverability is best thought of as a full end-to-end capability, not a single event. If you cannot practice it, measure it, and show it working, you do not truly have it. Restore tests are the most direct way to prove recoverability. A restore test is a controlled activity where you take a backup and attempt to recover data, systems, or services in a way that simulates real use. The purpose is not only to see if the backup can be read, but also to confirm that what comes back is correct, complete, and usable. A restore test can be small, like recovering a specific file and verifying its contents, or broader, like bringing back an application and confirming it behaves normally. The key is that restores should not be rare, special occasions. They should be routine enough that the process stays familiar and problems are found early. To make restore tests meaningful, they should reflect realistic recovery goals. If the organization has a defined recovery time objective, RTO, and recovery point objective, RPO, then tests should measure whether those objectives can be met. After the first mention, RTO and RPO should feel like the clocks and boundaries that shape the test. If you say you can restore a service within 4 hours, a test should measure how long it actually takes, including time to locate backups, initiate the restore, validate the result, and make the service usable. If you say you can lose no more than 30 minutes of data, a test should check whether the restored state meets that point in time expectation. Without tying tests to objectives, recovery planning becomes vague and easier to overestimate. One major misconception is that integrity checks are only about technical file corruption. They are also about logical integrity, meaning whether the recovered information makes sense in the context of the business. For example, a restored customer database might open correctly, but the newest records might be missing or duplicated. A restored system might boot, but it might have configuration drift that breaks integrations with other services. Logical integrity requires validation steps that compare expected outcomes to actual outcomes. This is where having clear expectations and simple verification methods becomes important. The goal is not to prove perfection, but to catch obvious misalignment and unexpected gaps before the restored environment is trusted again. Restore tests also reveal dependency problems, which are a common reason recovery plans fail. Many systems rely on other systems, such as identity services, network services, third-party connections, or supporting databases. A restore plan that focuses only on one component may look good on paper, but fail in practice because a dependency was not restored or was restored in the wrong order. Tests expose these gaps by forcing the environment to operate, not just exist. When a restored application cannot authenticate users, that is a dependency failure. When a restored service cannot reach a required data store, that is a dependency failure. Over time, testing helps teams map the true recovery sequence and avoid surprises. Another important aspect of restore testing is choosing the right level of realism. If you always test only the easiest restore type, such as pulling a single file, you might miss the harder scenarios that matter most. If you only test full system restores but never practice smaller, faster restores, you might waste time during an incident by using heavy methods when a simpler approach would work. The best mindset is to test multiple kinds of restores over time so you understand what is possible and how long each approach takes. The details of test design can be adjusted to the organization's size and complexity, but the principle is that testing should match the variety of real incidents. Documentation is what turns testing into evidence, and evidence is what turns recovery into a trusted capability. Documented results capture what was tested, when it was tested, what was restored, what success looked like, and what problems were found. Without documentation, tests become stories that people remember differently and cannot prove. Documentation also helps the next person who has to do the restore, especially during a stressful incident where clear guidance matters. It creates a living record of what works, what failed, and what improvements were made. When documentation is treated as part of the test, not as an afterthought, it becomes a powerful tool for reliability and accountability. When documenting results, it helps to capture both outcomes and metrics. Outcomes include whether the restore succeeded, whether data was complete, and whether services functioned correctly. Metrics include how long the restore took, how much data was restored, and whether the restored point in time aligned with our PO. It can also include observations such as which steps caused delays, which dependencies were tricky, and which approvals or access constraints slowed progress. These details are not about blame. They are about learning what needs improvement. If tests consistently miss our TO by an hour because of manual steps, that is a signal that processes or tools need adjustment. It is also worth recognizing that restore tests and integrity checks are not only for disaster scenarios. They help with everyday resilience, like recovering from accidental deletion, repairing corruption after a failed update, or restoring data after a system misconfiguration. Frequent, smaller recoveries build confidence and skill, which makes large recoveries more likely to succeed when the stakes are high. This is similar to practicing basic safety drills. You do not practice because you expect disaster every day, but because practice makes the response more automatic and less chaotic when something does happen. A subtle but important concept is that proof of recoverability should be current. A restore test performed a year ago may not reflect today's systems, data volumes, or dependencies. Environments change constantly, and recovery plans can quietly become outdated. Regular testing keeps proof aligned with reality. It also provides early warning when changes introduce new risks, such as a new application dependency or a backup configuration that no longer covers a critical dataset. The more frequently systems change, the more important it is to keep recovery proof fresh and relevant. To close, proving recoverability means moving beyond the comfort of knowing backups exist and into the discipline of demonstrating that restoration works reliably. Restore tests show that data and services can be brought back in usable form. Integrity checks confirm that what you restore can be trusted, and documented results create lasting evidence that recovery is real and improving. Together, these practices reduce surprises, expose hidden dependencies, and align recovery capabilities with real objectives. When organizations can prove recoverability, they respond to incidents with confidence instead of guesswork. That confidence is not built during an emergency. It is built through steady testing, validation, and documentation long before the emergency arrives.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.